So hello everyone, welcome to this session. So in this session we are going to start with the mixed type problems. Okay, till now we have discussed all the type 1, type 2, type 3 kind of problems, right? So in that we have seen the various forms of r of x in case of non-homogeneous function, that is where r of x is not equal to 0. So now we are going to discuss with one more type, that is mixed type problems. This mixed type problems means the word itself says mixed. So this would be consisting r of x, where r of x would be having all the types, that is type 1, type 2 and type 3. Okay. So here in this question we can see that, the given question is d cube minus 1 into y is equal to 3 cos 2x plus e power x. Okay, see these two are not of same kind, right? Here r of x, see this is the type 2 form where trigonometric function cos, it's of the form cos ax, and this is of the form e power ax. Okay, these two are from different types, right? So r of x will contain all the different types. Okay, yeah. So the procedure remains the same, that is we need to split r of x to find the particular integral. We need to split this term and this term separately to find yp1 and yp2. Then we need to add those yp1 and yp2 to get your particular integral. But the first step again remains the same for this thing, that is we need to find the complementary function. So the procedure here is, we need to put d is equal to m, first thing, right, according to the auxiliary equation. So now this would be m cube plus 0 m square, these terms are missing, right, minus 1 is equal to 0. So here this is again of the form of cubic polynomial. Take the coefficients 1, 0, 0, 1, and now we need to find the first root. I have written the equation in the calculator, x cube minus 1. So now press the calc button, check for 0. No, now we need to check for 1. Yeah, see, for 1 the value of this term is 0. So our first root is m equal to 1. So this 1 comes down, 1 ones are 1, 0 plus 1 is 1. Again 1 ones are 1, 0 plus 1 is 1. So this is minus 1, right? Yeah, so again 1 ones are 1, minus 1 plus 1 is 0. So our required polynomial is m square plus m plus 1. We get this with the help of the coefficients. So now again this is of the form of quadratic polynomial. Find its roots, that is formula is minus b plus or minus square root of b square minus 4ac by 2a, right? Here the value of b is 1, so minus 1 plus or minus square root of 1 square is 1, minus 4 into 1 into 1, so 1 minus 4 divided by 2. And m is equal to minus 1 plus or minus square root of minus 3 by 2. Again this minus 3 is there, so we need to multiply I square inside. 3i square by 2. I'll do it here. Minus 1 plus or minus root 3 as it is, bring that I outside by 2. Yeah, so therefore we get our total roots as 1 comma minus 1 by 2 plus or minus square root of root 3 by 2i. So these are our total roots. Okay. So now we need to write the particular integral, that is first root is 1, so c1 e power x plus c2 cos, the value of beta is here, root 3 by 2 x plus c3 sin root 3 by 2x into e to the power alpha is minus 1 by 2x. Okay. So this is your complementary function. So now find the particular integral. Yeah, I have written the formula and I have written the corresponding values. That is f of d here is d cube minus 1 and r of x is 3 cos 2x plus e power x. So now we need to split the r of x into, now first for that we need to find yp1 is equal to, first term is 3 cos 2x divided by d cube minus 1. So here in this second type we need to replace d square, we need to replace d square by minus of a square, right? But here we don't have d square term, so we need to split this d cube as d into d square. Okay, again the value of a is 2, so this would be minus of 2 square equal to minus 4, right? So now yp1 would be 3 cos 2x divided by, split it first, d into d square minus 1. So yp1 would be 3 cos 2x divided by, the value of d square is now minus 4, so this would be minus 4d minus 1. So now we need to multiply whenever there is of the form, this form, so we need to multiply its conjugates, that is the numerator and denominator by its conjugates, minus 4d plus 1 divided by minus 4d plus 1. So now multiply these two terms. So after multiplying we get minus 4d into 3 cos 2x plus 3 cos 2x divided by, again denominator of the form a plus b minus b, so this would be minus 4d whole square minus 1 square. So yp1 would be, multiply this 4 into 3 first, minus 12 into d cos 2x plus 3 cos 2x divided by 4d whole square, that is 16d square minus 1. So yp1 is minus 12 into differentiation of cos 2x, right? It is, the differentiation of cos is minus, so minus 2 sin 2x plus 3 cos 2x divided by 16d square minus 1. yp1 would be, minus into minus is plus, 12 2s are 24 sin 2x divided by 16d square minus 1, split the terms, plus 3 cos 2x divided by 16d square minus 1. Okay. Yes, so now again in this we need to replace d square by minus of a square, where the value of a is 2, so this will be minus of 2 square equal to minus 4 again, right? So now yp1 would be 24 sin 2x divided by 16 into minus 4 into minus 1 plus 3 cos 2x divided by 16 into minus 4 into minus 1. So this would be 24 sin 2x divided by 16 4s are 64, 64 minus 64 minus 1 is minus 65 minus 3 cos 2x by, here it is minus 65, right? So I have written minus up here, it would be 65. So our final yp1 which we are getting is minus 24 sin 2x minus 3 cos 2x by 65. So this is the yp1. So now similarly we need to find yp2, where the value of r of x is now e power x divided by d cube minus 1. So here we need to replace d by a, where the value of a here is 1. So yp2 would be e power x divided by 1 cube minus 1, that is equal to e power x by 1 cube is 1 and 1 minus 1 is 0. Okay, since f of d is equal to 0, now we need to take f dash of d, that is d cube minus 1's derivative 3d square, and 1's derivative is 0. So now yp2 would be, since we have taken the derivative, we need to multiply x in the numerator divided by 3 into value of, again a is 1, so 3 1 square, so yp2 is x e power x divided by 1 square is 1, 3. Okay, so this is your yp2. So our final yp would be equal to yp1 plus yp2, right? That is yp, we get it as minus 24 sin 2x minus 3 cos 2x by 65 plus x e power x by 3. So this is your yp, right? So similarly now we can write the final answer, that is our general solution. Okay, that is y is equal to yc plus yp. So our y is what we got? yc c1 e power x plus c2 cos root 3 by 2x plus c3 sin root 3 by 2x e to the power minus half x. This is your yc plus the yp, that is minus 24 sin 2x minus 3 cos 2x by 65 plus x e power x by 3, right? So this is your final answer. So in this way we need to solve the mixed type problems. Okay, so we are going to solve one more problem in this session. I'll get you the question. So this is your second question. D cube plus 2d square plus d into y is equal to e power minus x plus sine 2x. So here r of x is again in two terms, so we need to find yp1 and yp2 first. So here again this is of the mixed type, where this is of the form e power ax and this is of the form sine ax, right? So the first step remains the same for all the problems that I have told you. First put d is equal to m according to the auxiliary equation. So now it would be m cube plus 2m square plus m is equal to 0. Again this is of the form cubic polynomial, cube, right? Write the coefficients 1, 2, 1, 0. So here our first root is obviously 0, because if we put the value of m equal to 0 in all the cases, so we get 0 cube plus 2 into 0 square plus 0, that is equal to 0 itself, right? Yeah, so first we'll bring it down. 0 1s are 0, 2 plus 0 is 2, again 0 2 is a 0, 1 plus 0 is 1, 0 1s are 0, right? So we get m square plus 2m plus 1 equal to 0, right? So now find its roots. The value of b is 2, so minus 2 plus or minus square root of 2 square is 4 minus 4ac, that is again 4 divided by 2. So we get minus 2 plus or minus 4 minus 4 is 0, right? So we get minus 2 by 2 comma minus 2 by 2, repeating twice. So our total roots which we get here is m is equal to, first root here is 0 comma minus 1 comma minus 1. So now we are going to write the complementary function, that is c1 into e to the power 0x, right? The first root is 0, so e to the power 0, anything to the power 0 is 1, so only c1 would be left, plus c2 plus c3x, because these two roots are repeating, into e to the power, the root here is minus 1, so minus x. This is your complementary function. So now we need to find the particular integral, that is 1 by f of d here is d cube plus 2d square plus d into e to the power minus x plus sine 2x. So now first consider e to the power minus x, so first we need to find yp1, that is e to the power minus x divided by d cube plus 2d square plus d. So now here the value of a equal to 1, so we need to replace a by d, so now it will be e to the power minus x divided by 1 cube plus 2 into 1 square plus 1. So we get yp1 as e to the power minus x divided by 1 cube is 1, 2 1s are 2, so 1 plus 2 plus 1 is 4, right? So here the value of a is, see I have made a mistake here, is minus 1, right? Yeah, so this would be minus 1 cube and minus 1, so this would be minus 1 plus 2 minus 1, so that is we get yp1 as e power minus x divided by minus 1 is minus 2 plus 2 is 0. See, we should not make these mistakes, okay? So I am in a hurry to solve the problem, so that's why I am making the mistakes, okay? Yeah. So here since again f of d is 0, so now we need to find f dash of d, right? So f dash of d, the given f of d is d cube plus 2d square plus d. So now its derivative of d cube is 3d square plus derivative of 2d square is 4d and the derivative of d is 1, right? So now yp1 would be looking like, multiply x, since we have taken its derivative, 3 into the value of again a is minus 1, so minus 1 square plus 4 into minus 1 plus 1, so we get yp1 as x e power minus x divided by minus 1 the whole square is plus 1, so 3 minus 4 plus 1, again we get yp1 as x e power minus x divided by 3 plus 1 is 4 and 4 minus 4 is 0. Okay, so now again we need to take the derivative of f dash of d. Okay, so again we need to take the derivative of f dash of d, that is f double dash of d, where the given f dash of d is 3d square plus 4d plus 1. So the derivative of 3d square is 3 to the 6d plus 4 and the 1 is 0. Okay, so now our yp1 would be looking like, we had x, right? Again we need to multiply x, so it would be x square e power minus x divided by 6 into the value of a is again minus 1 plus 4, so yp1 we get it as x square e power minus x divided by minus 6 plus 4, right? 6 into minus 1 is minus 6 plus 4 is minus 2. Okay, so the final yp1 we get it as minus x square e power minus x by 2, right? Okay, so now in the same way we find yp2, our function is sine 2x divided by f of d is d cube plus 2d square plus d. Okay, so here again we need to replace d square by minus of a square, where the value of a is 2, so minus of 2 square is minus 4 again, so yp2 would be, yeah, so here we have directly one d square term, but here also we have d square. Okay, since there is d cube, we can split it and write it as d into d square, right? Yeah, so we can write it as sine 2x divided by d into d square plus 2d square plus d, right? Sine 2x is equal to d into d square is minus 4 plus 2 into minus 4 plus d, so this would be sine 2x divided by minus 4d minus 8 plus d. Okay, so finally we get yp2 as sine 2x divided by minus 4d plus d, that is minus 3d, and the remaining term is minus 8. So now we need to take its conjugate and multiply the numerator and denominator by it, that is minus 3d, so this is minus 8, so it will be plus 8 minus 3d plus 8. Yeah, so now multiply the terms, minus 3d sine 2x plus 8 minus 3d sine 2x plus 8 sine 2x divided by again a plus b, a minus b form, so it would be minus 3d whole square plus 8 minus 8 square. Okay, so again minus 3 into derivation of sine 2x, the derivation of sine x is cos x, so since there is sine 2x, so 2 cos 2x plus 8 sine 2x divided by 3d the whole square, so it is 9d square minus 64, right? So now yp2 would be minus 6 cos 2x divided by 9d square minus 64 plus 8 sine 2x 9d square minus 64, right? So now here we need to replace d square by minus of a square, where the value of a here is 2, right? So it will be minus of 2 square equal to minus 4 again, so minus 6 cos 2x divided by 9 into minus 4 minus 64 plus 8 sine 2x divided by 9 into minus 4 minus 64. So here in the denominator, so now we will get 9 4s are 36 minus 36 minus 64. that is equal to minus 100. Okay, so we get 6 cos 2x by 100. So we had minus sign in both numerator and denominator, so I have cancelled it. So here in the denominator again we get minus, so this would, I will change this to minus 8 sin 2x upon 100. Okay, so we can further make this simplify, right? So 6 we can take 2 3s are and 2 50s are, 2 4s are and 2 50s are, right? Yeah, so we get yp2 as 3 cos 2x minus 4 sin 2x divided by 50. So this is your required yp2. So now we need to add yp1 and yp2. So now yp would be yp1 plus yp2. So yp is equal to, yp1 we got it as minus x square e power minus x by 2 plus yp2 we got as 3 cos 2x minus 4 sin 2x upon 50, right? Yeah. So this is our required yp particular integral. So now our general solution will be looking like y is equal to complementary function along with the particular integral. We need to add them. So our y is equal to complementary function, we got it as c1 plus c2 plus c3x into e power, the root is here minus x. So this is our yc plus the particular integral is x minus of x square e power minus x by 2 plus 3 cos 2x minus 4 sin 2x upon 50, right? So this is your final general solution for this problem. Okay, so now here we have solved 2 problems, right, in this session. So in this way we need to find all the mixed type problems. Okay, so in the next session I am going to continue with some more mixed type problems with more terms including in the R of x, which are some of the lengthy problems. Okay, we are going to solve 2 lengthy problems in the next session considering of these mixed type functions. Yeah, so that's all. Thank you.